Okay, let's try and use the simple steps to solve a right triangle. The first case we'll deal with is this triangle right here. Okay, so if we were asked to solve this, let's follow the steps. The first step says to choose your reference angle. The reference angle that we're going to choose is, of course, going to be this one, the one that it gives us. Now, the second step says, with reference to that angle, choose the appropriate trig ratio. So, with reference to that angle, we can see that we have the side that's across from it, so that's the opposite. And with reference to this angle, we also have the hypotenuse, the side that's across, that's the side that's across from the right angle. Let me fix this. Hypotenuse. Okay, so if we have the opposite and the hypotenuse, then obviously if we're looking at SOHCAHTOA, the appropriate trig ratio would be SO, or sine of theta is equal to opposite over hypotenuse. So we should start everything with the formula, and now we can plug in. So sine of theta, our reference angle is 30 degrees, is equal to opposite, which in this case is x, over 20. So I like to call this the multiply technique. Because to solve for x here, the only thing that we have to do is multiply this 20 to the other side. So we get 20 sine 30 is equal to x, and when you type that into a calculator, you're going to get 10, and the units on that was centimeters. So there you go. That's how to do this first case. Let's use the simple steps to solve a new triangle. This one. So with reference, so the first step is to choose your reference angle. The reference angle that I'll choose is the one that's given, 60 degrees. With reference to that angle, what do I have? Well, I have the side that's across from the right angle, so that's going to be my hypotenuse. And then I have the side that's touching the angle, that's not across from it, but beside it, so that's my adjacent. So with reference to this angle, we have the adjacent and the hypotenuse, so that would refer to the CA, or cos of theta, is equal to adjacent over hypotenuse. And now we fill in, so cos of 60 is equal to adjacent over hypotenuse. Our adjacent in this case is 13, and the hypotenuse is x, and I like to call this the switch technique. Because to solve for x, it's in the bottom here, it's in the denominator. To solve for x, you switch it with the thing that's on top on the other side. So the x will go in this place, and I'll switch it with the cos 60. So these two swap spots. So you type that into your calculator, and you get 26, and the units on this is millimeters. Okay, let's use the simple steps to solve a different triangle. Let's do this one here. So the first step says to choose your reference angle. I have to choose theta since that's the one that I'm trying to find. With reference to that angle, let's see what I have. I have the the opposite. So the side that's across from the reference angle, and then since this is clearly the right angle, I have the adjacent, the side that's left over, since this is my hypotenuse. So since I have the opposite and the adjacent, that would infer TOA, which means that tan of theta is equal to opposite over adjacent. And now I fill in. So tan of theta is equal to 32 over 19. And to solve for this, I call this the inverse technique. That's when I'm solving for an angle. So theta is going to be equal to move the tan on the other side, I take the tan inverse of 32 over 19. So I'll type that in my calculator. I get 59.3 degrees.